Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In this session, we are going to study about a secular trend in detail again. In the previous sessions, we talked about economic time series and various components of time series. Methods to calculate the components of time series were also discussed. Also, calculating secular trend by freehand or graphical method and method of least squares have been dealt. In this session, we are also going to deal with the secular trend calculations by the method of least squares, wherein the summation x is not equal to 0, and also some examples have been worked out in finding the trend values by the method of moving averages. Fit a straight line trend by the method of least squares to the following data and find the trend values. Here, the number of years given is 6, that is 2005, 2006, 2007, 2008, 9, 10, that is 6 values are given. So, even number of values are given. There is no mid year, so that we take the mid year as the origin and compute summation x as 0. There is no mid year to take that as origin and compute summation x as 0. Here there are 2 mid values, one is 2007 and 2000, another one is 2008. Any one of these values can be taken as origin for conversion of the year values, x values to origins. That is, year is given as 2005 to 2010, and sale of air conditioners in lakhs has been given as 10 lakhs for the year 2005 and 13 lakhs for 2006, 16, 21, 24, 30 respectively from 2007 to 2010. So, we have to fit a straight line trend by the method of least squares and find the trend values. Fitting straight line trend by the method of least squares, first take the value 2005. The corresponding sale values is given to be equal to 10 lakhs. So, 10 lakhs is just written as 10, and there are 6 values and 2007 and 2008 are mid years. So, we can take any one of these as origin. In this problem, we are taking 2007 as mid year. So, that is computed as 0, that is 2007 is taken as the origin. So, that 2005 minus 2007 it gives you minus 2, 2006 minus 2007 is minus 1, 2007 minus 2007 is 0, and 2008 minus 2007 is 1. Like that it is calculated. The important difference between this problem and the previous problem worked out in the previous session is the summation x is equal to 3 and it is not equal to 0. So, we cannot use the direct formula of a and b for fitting the straight line y is equal to a plus bx. We have to use another way. So, that is why this problem is different and is being calculated. Then as usual, just calculate x y. X is minus 2 and y is 10, therefore, minus 2 into 10 is minus 20. Like that all the values are calculated. Minus 1 into 13 is minus 13. Then x square is the square terms of x, therefore, x square is minus 2 whole square 4, minus 1 whole square is 1. And these trend values will be calculated later view based on the trend equation. Now, we see summation y is equal to 114 and n is equal to 6, that is number of years is 6 and summation x is 3, it is not equal to 0, that should be noted here, and summation xy is 126 and summation x square is 19. These trend values are yet to be calculated. Okay. So, we shall do this. Y is equal to a plus bx. The first equation is just formed by taking the summation as it is. So, summation y is equal to n into a plus b into summation x. What is summation y value? From the previous slide, summation y is 114 and summation x is 3. So, 114 is equal to n is 6 values are given. So, 6a plus b into 3. So, one equation is formed, that is 6a plus 3b is equal to 114. Okay. And another equation is formed by multiplying the straight line equation with x and then taking summation. This you can mark it as 1 and this equation as 2. So, multiply 1 with x and then take summation. So, xy is equal to ax plus bx square. So, take summation xy is equal to a into summation x plus b into summation x square. All the summation values are now written here by extracting it from the table. So, summation x is 3, summation xy is 126, summation x square is 19. That values has to be substituted there. 126 is equal to a into 3 plus b into summation x square is 19. So, you get 3a plus 19b is equal to 126. This is the third equation. Solving 2 and 3, we get, write the two equations together, that is 6a plus 3b is equal to 114 and 3a plus 19b is equal to 126. We have to solve. Solve in the sense, just multiply the second equation with 2 and then solve it. We get 6a plus 3b is equal to 114 and 6a plus 38b is equal to 252. 252. Just subtracting, we get minus 35b is equal to minus 138. So, that b is equal to 138 by 35 and this value comes to be equal to b is equal to 3.943. Now, substitute this b value in any of the second or third equation. We get 6a plus 3 into 3.943. I am substituting this in 2 is equal to 114. We get 6a is equal to 102.171. So, that a is equal to 17.029. So, the trend equation, therefore, the trend equation is y is equal to a plus bx, that is 17.029 plus 3.943 x. We obtained the straight line trend for the given data. Now, the trend values has to be calculated. For the first value, just see, it is 9.143. This value has to be obtained. For the corresponding x value is minus 2, we should get the trend value. For the year 2005, x is equal to minus 2. So, y at 2005 is equal to 17.029 plus 3.943 into minus 2. When you just calculate, this value comes to be equal to 9.143. So, that is what is tabulated there in the tabular column as 9.143 is the trend value just calculated for the year 2005. Likewise, all the values are calculated. This is 13.086 is the value corresponding to the year 2006, wherein x value is -1. Substitute x is equal to -1 in the trend equation. The y is equal to 17.029 plus 3.943 into -1. X is -1, right? Therefore, this y value at year 2006 comes to be equal to 13.086. Likewise, when x is equal to 0 for the year corresponding to 2007, the value is just 17.029. Likewise, 20.972 is just calculated, and 24.915 is calculated, and 28.858 is calculated. These are the trend values just calculated based on the trend equation found out. Now, after studying linear trend, that is straight line trend by graphical method and method of least squares, next we proceed to discuss about non-linear trends. The following are the methods of measuring non-linear trends. Freehand or graphic method, it is similar to the graphical method studied in linear trend. So, next method of moving averages or moving average method. We shall discuss this moving average method with an example. Illustration 4 goes like, calculate the 5-yearly and 7-yearly moving averages for the following data of a number of commercial industrial failures in a country during 1995 to 2010. So many number of years have been given. For calculating such big yearly moving averages, we need to have at least 10 values. From 1995 to 2010, here it goes like 16 values are given. That is, for the year 1995, number of industrial failures is 23, and for 1996 is 26, similarly 28, 32, 20, 12, 12, 10, and then for the year 2003, number of failures is 9, then for 2004 is 13, like that up to 2010, number of failures is 1. For this data, we have to calculate non-linear trend values by the method of moving averages. Here specifically we are asked to calculate 5-yearly moving averages and 7-yearly moving averages. Let us see how they are calculated. Calculation of 5-yearly and 7-yearly moving averages. First, this particular tabular column here gives you the 5-yearly and 7-yearly moving averages from the year 1995 to 2000, and the next tabular column gives you the values from 2001 to 2005. Because it is such a big tabular column, it has been broken and given in various slides. And then from 2006 to 2010, 5-yearly and 7-yearly moving averages are given. Let us see for the first tabular column how the 5-yearly moving averages are calculated. First of all, 5-yearly moving totals has to be calculated, then 5-yearly moving averages has to be calculated. Then similarly for 7-yearly moving total and 7-yearly moving averages. Let us see how they are calculated. Now, first 5-yearly moving total is the total of the first 5 values. Total of the first 5 values, that is 23 plus 26 plus 28 plus 32 plus 20. These first 5 values total is 129, and it is written in the middle of the first 5 values. The middle of first 5 values is 28, corresponding to the year 1997. For the first 5-yearly total, the middle of first 5 values is 28, and here it is written. This 129 is actually the total of 23 plus 26 plus 28 plus 32 plus 20 is 129. Similarly, 118 is the total of the next 5 years. Okay, that is 26 plus 28 plus 32 plus 20 plus 12, and it is written in the middle of the next 5 years. When you take these 5 values, the middle of these 5 values is 32, and hence it is written against this middle. Likewise, it is calculated. 104 is the total of 28 plus 32 plus 20 plus 12 plus 12. Like that the 5 yearly moving totals are calculated. Then 5 yearly moving averages. 5 yearly moving averages are calculated as 129 divided by 5. 129 by 5 gives you 25.8 or 26. Similarly, this 118 by 5 gives you 23.6 or 24. Similarly, here 104 by 5, that is the 5 yearly moving averages, 26, 24, 24, 17, etc. Okay. This is how 5 yearly moving averages are calculated. Next, 7 yearly moving totals. Now, 7 yearly moving totals is the total of 7 values. First 7 values. What is the first 7 values? 153 is obtained by adding the first 7 values and it is written in the middle of the first 7 values. So, 23 plus 26 plus 28 plus 32 plus 20 plus 12 plus 12 gives you 7 yearly moving total as 153 and it is written in the middle of the first 7 values. The middle of first 7 values is for the corresponding to the year 1998 and it is 153. Next, 153 divided by 7 gives you 21.9 or 22. Similarly, 140 is calculated as the 7 yearly moving total leaving the first value, because the first 7 values is constituted with 153. Leaving the first value, second value, third value, fourth, fifth value, sixth value, seventh, eighth is the next 7 values, that total is given as 140. So, that is 140 is obtained by adding 26 plus 28 plus 32 plus 20 plus 12 plus 12 plus 10 and it is written in the middle of the 7 values. Middle of the next 7 values is 20 corresponding to the year 1999 and its moving average is 140 divided by 7 is 20. Like that 5 yearly moving totals are calculated and 5 yearly moving averages, 7 yearly moving totals and 7 yearly moving averages are calculated. We can check up with this values. Next, 5 yearly and 7 yearly, 5 and 7 are odd numbers. So, writing the values for against the mid value is easier, because for when you calculate the first 5 values, the third value is the mid value. So, against the third mid value we can write the 5 yearly moving averages. Whereas, when you talk about 4 yearly moving averages, we have to add first of all first 4 totals, first 4 values total, and where will you write first 4 values means first value, second value, third value, fourth value we have to add. So, writing the 4 yearly moving total is only between the second value and third value, because second and third are the 2 midpoints. So, between second and third we have to just put an arrow mark and write the 4 yearly moving total. Okay. And then 4 yearly moving average has to be written just next to 4 yearly moving total. Let us see how this is calculated. This is the data given in the question from 1999 to 2009. Year is 1999, 2000, 2001, 2, 3 and then corresponding to the year 2004, the value is 1317. Next, for 2005, 1452, 2006, 1549, 2007, 1586, 2008, 1476 and then for 2009, 1624 and then for 2010, it is 1586. Let us see how 4 yearly centered moving averages are calculated. Calculation of 4 yearly moving averages. First of all, take the years 1999 1999, 2000, 2001, 2002. Y values are 1102, 1250, 1180 and then 1340. The mid values from 1999 to 2002 is between 2000 to 2001. So, the total of the first 4 values is written in between 2000 and 2001, that is 1102, 1250, 1180, then 1340. All the 4 values are added and their total is written here as a 4872. It is like you take year values, I will just write it for the first 4. Y values is 1102, 1250, 1180, then 1340. 4 yearly moving total is written here in between 2000 and 2001. There is no extra row or extra year value between 2000 and 2001. You just for centering the values it is written like this. So, 4 yearly moving total is 4872 and then 4 yearly moving average for that is 4872 divided by 4. 4872 divided by 4. Always average is total values as the sum of the values divided by the number of the values, isn't it? So, that value is 1218. Likewise, it is calculated. Similarly, if the year is 2003, the value is 1212, this 4872 is the total of these first 4. Then, for the next 4 values, the value is written here. For the year 2000 to 2003, 2000, 2001, 2, 3, the value is written in between 2001 and 2002 and the value is 4982 and its average is 4982 divided by 4 is 1245.5. Okay. Similarly, the values are calculated for after leaving 1999 and 2000. The next 4 values are added corresponding to the years 2001, 2002, 2003, 2004. That value is written in between 1340 and 1212. Just add the 4 values and write it here and calculate and write it. This is in straight line. Okay. When you see 1218 does not have any corresponding year here because it is written in between 2000 and 2001. Now, next we cannot calculate the trend values when it is written in between the years. Therefore, we have to center that value. That is what is called a 4 yearly centering or centered values. That is written here as 1218 plus 1245.5 divided by 2. That value comes to be equal to 1231.75. So, when you just see the arrow mark corresponds to the year 2001. Okay. So, the trend value for the first 2 years is not possible for when you are calculating 4 yearly centered moving averages and the trend value for the year 2001 is 1231.75. Likewise, the values are calculated corresponding to the year 2002 and 2003 and henceforth. See the table column. We see we have calculated the totals of total of the 4 values 1102 plus 1250 plus 1180 plus 1340, that gives you 4872, that is divided by 4. 4872 by 4 gives you 1218. Similarly, the next 4 values are calculated and written as 4982 and 4982 divided by 4 is 1245.5. Since there is no year corresponding to these values, it has to be centered. Therefore, the centered value is 1218 plus 1245.5 divided by 2. That value is 1231.75. We have just calculated it and it is written. Okay. Similarly, the values are calculated. It is centered these 2 divided by 2 is centered. So, centered in the sense there must be an year corresponding to their particular trend value. So, these are the 4 yearly centered moving averages. In this session, we have calculated trend values, linear trend and non-linear trend. For linear trend, when the number of years is even, then summation x will not be equal to 0. We used the normal equations to obtain the trend line, and using the trend line we have calculated trend values. Next, we have calculated the non-linear trend values, that is wherein the straight line equation will not be there, and we have calculated non-linear trend values by the method of moving averages. Examples have been worked out in calculating 5 yearly, 7 yearly and 4 yearly centered moving averages. Based on the discussion in this session, the following question may be posed. Number of units produced during 2003 to 2010 data has been given. Fit a straight line trend and obtain the trend values. Also, estimate the trend value for the future year 2012. Thank you.